Good morning to the class. Today we are going to learn about the Planck's quantum theory and different models of the atoms also. So before going to the today's class, once we will remember the previous class also. See children, in the previous class we learned about the visible spectrum and the electromagnetic spectrum. So visible spectrum. In the visible spectrum, the colors of light we can see only from red to violet color with the different intensities and with the different frequencies also. And as well as in the electromagnetic spectrum, we can see the light. We can see the light along with the infrared rays and ultraviolet rays. In between we have the visible spectrum also. You can see in the picture also. See, ultraviolet rays means UV rays and infrared rays also we have. So in between these we can able to see the colors from blue color to red color. This is the visible spectrum we can see, and along with this visible spectrum, whatever the infrared rays and here we have this ultraviolet rays, these all will be called as the electromagnetic spectrum. So for example, when we heat the iron rod, the light energy will be first, means the heat energy will be first emitted as the light. So first if you take one iron rod and if you heat that iron rod, means we are giving some heat energy to the iron rod. So after some time the heat energy will be emitted as in the form of light. So the light will be first we can see in the red color, and after that we can see that red will be changes into orange. After the orange we can able to see the blue color light also. And not only that, if you continue the heat energy like that, so finally we can able to see the white color light also. So when the temperature is high enough, means when we are increasing the temperature, means when we are continuously giving the temperature to any object, we can able to observe some different colors also will be emitted from that. So because of high intensity of one particular color, and we can't see the other colors also. So whenever we are giving the continuous heat energy to any object, we can able to see some we can able to see only one color, but in that particular time the different colors also will be emitted. But why we are not able to see the different colors and why we can see only one color? Because of the high intensity of only one color, we can see that particular color. So which color have high intensity, we can see that only one color, and remaining colors they have the less intensity when compared to the first one. That's why we are not able to see. But anyway, the different colors also will be emitted, but we are not able to observe them because of the higher intensity of light and lower intensity of light. So in this way, when we are giving the continuous heat energy according to the scattering phenomena of light. So did you remember the scattering phenomena? Whenever we are giving the light energy to any object, according to its wavelength, some energy will be emitted from that object. According to the wavelength, it will emit the light energy. So in this way, according to the scattering phenomena, the light will be the light energy will be emitted in the multiples of hv, not in a continuous manner. The multiples of hv means whenever we are giving the heat energy, to any object, means when the light will be supposed to be on one atom or one object, from that particular object or from that particular atom some energy will be emitted. So how much energy will be emitted? That should be in the multiples of h mu form. That is the multiples of h mu form, and it is not in the continuous form. So multiples, do you know multiples? So for example, if you want to write the multiples of 3, 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, like that. Those are the multiple forms. So here multiples of h mu means 1 h mu, 2 h mu, 3 h mu, 4 h mu, like that. So those are not in the continuous manner. The emitted energy from the object will be in the multiple form. Okay, it is in the multiple form. So here you see, in this way, when we are giving the continuous heat energy according to the scattering phenomena of light, the energy will be emitted in the multiples of h mu. So finally E is equal to h mu here. E is equal to h mu. So here what is the meaning of mu? E is emitted energy from the object or from any atom. The emitted energy will be taken as E, and mu is the frequency of the light, and here h is nothing but the Planck's constant. Planck's constant, and this is the constant value, and it should be taken as 6.626 into 10 power minus 34 joule seconds. So why we are taking the joule seconds? Joules is the Celsius unit of temperature, and seconds is the joules is the Celsius unit of energy, and so these seconds will be the time. Okay, means we will take this one as the reciprocal for the frequency also. So frequency will be always we are writing as a reciprocal of seconds. So that's why the Planck's constant is a constant value. This should be we are taken as 6.62 into 10 power minus 34 joule seconds. Minus 34 joule seconds, and mu is the frequency of the radiation of the emitted energy or absorbed energy. So finally in this visible spectrum, the energy for red color is lower when compared to the blue color. In the visible spectrum, here you see, in the visible spectrum the red color has the red color will be in the lower form, and the blue color has in the higher form, because see the emitted energy of object or atom will be depends upon mainly increasing the heat energy. So when we are increasing the heat energy, so in the example also we can observe, when we are heating the iron rod, first we can able to see the light is in the red form, and after that, after some time only we are getting the blue color light. So whenever we are increasing the heat energy here, first we can see the red color, after that we can go for the we are getting the blue color light. So if the heat energy will be increases, the intensity of light also will be increases. So the intensity of light will be always depends upon the increasing of heat energy here. So the significance of Planck's theory. See, what is the Planck's theory? See, here you see, children, the significance of Planck's proposal is that the electromagnetic energy can be gained or lost in discrete values and not in a continuous manner. So whatever the energy, whatever the heat energy, and whatever the light energy will be gained or lost from the object, it should be always in the discrete manner and not in a continuous manner. It should be always in discrete values. Discrete values means some distinct values, some separate values, means multiples we are taken, not in the continuous manner. Continuous means we are adding 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1, not in that way. We are taken as the multiple values. Multiples means 1 h mu, 2 h mu, 3 h mu, like that we are taken the multiples. So this is the Planck's quantum theory. Once again you see, the significance of Planck's proposal is that the electromagnetic energy can be gained or lost in discrete values and not in a continuous manner. So finally, the emission or absorption of light spectrum is the collection of a group of wavelengths. So the group of wavelengths, means the colors of light. So whatever the colors of light we have in the electromagnetic spectrum will be it is the emission or the absorption of light spectrum. Emission or absorption of light spectrum. So this should be we are taken as the visible spectrum. Not only visible spectrum, in the electromagnetic spectrum also, whatever the visible spectrum we have and invisible spectrum we have, these all will be the group of collection of emission and absorption of lights. Emission and absorption of light will be called, we are taken as the group of wavelengths. Group of wavelengths are nothing but group of colors. Group of colors we have. So in Diwali time we can enjoy the crackers. We can enjoy with the crackers. See, in the crackers, if you burn the crackers, we can get some different colors with the different intensities. So we enjoyed a lot with them. But how we are getting that colors and how we are getting that different intensities of light? So in that crackers, whatever the whatever the things and whatever the chemicals we are using, they will give some different colors, they will emit some different colors of light. So here each and every element, so whatever the chemicals we are using in the crackers, means sodium, some carbon, or some strontium, cupric chloride, these all will be the different elements, and they have some different, they have the different, they will able to emit the different colors of light also because of their different wavelengths. So here each and every element, they will give some, each and every element have the separate wavelength, and they will, according to their wavelength, they will emit some different colors of light with a different intensity. So for example, here we have one small activity to know about these elements, what they will emit, the how they will emit the light energy. See here. So if you take the pinch of cupric chloride, it is in the powder form actually. So if you take the pinch of cupric chloride, and it will mixed with the concentrated hydrochloric acid. If you mix this one with the concentrated hydrochloric acid, then we can get one paste, we can get some paste form. That should be, we have to place on the non-luminous flame. That should be, that paste we have to take, and again you have to suppose it one on the non-luminous flame. Then finally the one light energy will be emitted from that, that should be in a green color. Exactly, it is in a dark green color only. So this cupric chloride will emit the light energy which is in the form of a green color. And as well as in the same way, instead of this cupric chloride, if you are taking the strontium chloride, so again strontium chloride also will be added with the concentrated hydrochloric acid, and again we are getting the paste. That paste again you have to supposed to be on the non-luminous flame. Again it will give some other color of light, that should be the red color, light red color. So that red color flame we can able to see. So here in this example, if you observe, the strontium chloride will gives the green color light, and here the strontium chloride, cupric chloride will gives the green color light, and strontium chloride will gives the red color light. So here each and every element, they have their own character to emit some different color of light and with different intensities. So scientists found that each element emits its own characteristic color. These colors correspond to certain discrete wavelengths of light and are called as the line spectra. It should be called as the line spectra. See, each and every element, it has its own character, and they will, according to their character, they will emit their discrete wavelengths of different colors, and that different colors of lines will be called as the line spectra. This line spectra will be very useful to us to know about the different whatever the atoms, and what about its wavelength. According to the wavelength, what is the frequency of light will be there, and according to that, due to this one only, we can able to understand what are the different atoms, how many number of atoms are there, and how they exist in that particular object. So these all will be, we can able to understand by using this line spectrum. So the lines in atomic spectra can be used to identify the unknown atoms. So unknown atoms, so up to here we don't know, we know only the atoms will be there, and but we don't know what is the structure of the atom, and what is the internal structure, and how they will be placed, how they will exist in the atom. That structure we don't know. So by using this line spectrum only, we can able to see, we can able to understand the structure of the atom. So just like simply how the fingerprints will be able to use to know the identification of the persons or identification of people here. So the line spectra will be very useful to us to know about the spectrum of structure of the atom. So by using this line spectra also, here we have the Bohr's model of the atom, and some Sommerfeld atoms structures also there. So those we can go for the next class, children. Everyone should read, should follow the class properly, and you should read the textbook. Thank you.